Percentage composition. Chemical formulas and chemical equations have quantitative significance. Subscripts and coefficients represent precise quantities. Ratios of atoms to each other in molecular formula are exact and cannot change without changing the molecule. So let's look at percentage composition of compounds. How can we determine the percentage of carbon in glucose? What exactly do we need to know? The chemical formula gives us the ratio of the atoms to each other. Glucose, C6H12O6. That gives us the ratios. It is always the same. For every 6 carbon atoms, there are 6 oxygen atoms and 12 hydrogen atoms. This means that irrespective of how much glucose there is, the percentage of carbon should be the same. Not all atoms have the same relative mass. Formula ratio and relative mass are required. The periodic table gives relative masses in terms of atomic mass units, and this is what we rely on for guidance. On the periodic table, as you will see, the elements are listed and atomic mass units are given. 12.011 for carbon, for instance, and 55.847 for iron, 1.0079 for hydrogen, and so on. It is these masses which we use when we look at percentage composition by mass of any compound that we are looking at. So let's continue and look at the mass percentage of carbon, which is in glucose. 6 atoms of carbon. We have to look at the mass from the periodic table, so we can say that 6 times 12.01 atomic mass units, plus for hydrogen 12 times 1.01 atomic mass units, plus for oxygen 6 times 15.99 atomic mass units. If we add all of this together, we get 180.12 atomic mass units for the glucose molecule. Now we want the percentage carbon by mass in every molecule of glucose. So there are 6 carbon atoms. That is 72.06 atomic mass units. And we divide that by the total molecular mass, 180.12 atomic mass units. Atomic mass units cancel. We multiply by 100 to get percentage, and you should get a value of 40.01% carbon by mass in every glucose molecule. Let's look at another example. Let's consider the percentage of nitrogen by mass in calcium nitrate. Now, once again, we need the molecular mass of calcium nitrate, and calcium is 40.08. Nitrogen, there are 2 atoms of nitrogen. Look carefully, there are brackets, 2, so it's 2 times 14.01, and there are 3 oxygens in the nitrate molecule, but look, there are brackets, it's 3 multiplied by 2, so that is 15.99 multiplied by 6. That total should give us an atomic mass of 164.08 atomic mass units. Now we want the percentage of nitrogen only. There are 2 nitrogen atoms, so that is 2 times 14.01. So we have to take 28.02 and divide it by 164.08. This should give us and multiply by 100 for percentage, which should give us a value of 17.07% nitrogen by mass for the amount of nitrogen in calcium nitrate. You could be given a question that looks like this. Now, you have to understand what the molecule represents. The first molecule is carbon dioxide. You have one atom of carbon, that's 1 times 12.01, plus 2 atoms of oxygen, it's 2 times 15.99 to get the molecular mass. The molecular mass there will then be 43.99 atomic mass units. There's only one atom of carbon, so 12.01 divided by 43.99 multiplied by 100 should give you an amount of 27.3% carbon by mass in carbon dioxide. The next molecule is an alcohol, the simplest alcohol, methyl alcohol. There's one carbon atom, so it's 1 times 12.01. There's one oxygen, 1 times 15.99, and there are 4 hydrogens, so it's 4 times 1.01, which should give you a total of 32.04. You're looking for carbon. There is only one carbon, so you take 12.01, you divide it by 32.04, and when you multiply by 100, you should get a value of 37.48% carbon by mass in methanol. As we go further down, we see the next molecule that we look at is ethane. Ethane has 2 carbon atoms and 6 hydrogen atoms, and you should get the molecular mass to come to 30.08. Now we're looking at the percentage of carbon by mass. There are 2 carbon atoms, which is 24.02. Dividing these and multiplying by 100, you should get a value of 79.8% carbon by mass in ethane. Finally, this molecule here may not be so easy to distinguish. There are actually 2 nitrogen atoms, 1 carbon, 1 sulfur, and 4 hydrogens. So you have 12.01, that's the carbon, plus 14.01 times 2 for the nitrogen, plus 32.06 for the sulfur, plus 1.01 times 4 for the hydrogen, which totals up to 76.13. 76.13 atomic mass units. Now you're looking for the percentage of carbon, so you have to take, there's only one carbon atom, 12.01 divided by 76.13 multiplied by 100, and you should get an answer of 15.78%. That was fairly straightforward. This is the quiz at the end of this section. There are 2 questions which you once again must submit on the MyTutor platform. First one, what is the mass of carbon in dimethyl sulfoxide? The formula is given. Each answer is rounded to 3 significant figures. One of these answers should be the answer that you obtain if you have worked this out correctly. The second question asks for the percentage of aluminium by mass in aluminium sulfate. Once again, the formula is given. One of these answers must be selected and submitted. You will be immediately notified if your answer is correct.